Dr. Jeff Daniels.
Thank you. Thank you. Thank you very much. I wanted to put a call out to a reference. We had a Chalk Talk yesterday with Steve Girali and Greg Doppelauer. If you missed it, hopefully you can catch the replay. Many of us from the organization are here representing, so good reference. If you got a chance to be in Dirk's IoT session yesterday, he covered a few organizations, Volkswagen, Hunter, and Lockheed Martin. It's worth going back and looking at, but I'm going to talk in depth about the industrial Internet of Things and our journey at Lockheed Martin today. So first of all, I want to say thank you for being here. I know you have choices. I hope you've had a good week. I came ready to talk about the future of work, and I walked through the expo hall, and I don't know if anyone's done that. It's really neat. But I saw something strange, and it was typewriters. And it took me way back. Many of you have probably used typewriters, but I got a comment from one of the people working there, and she said, she was helping someone fix a typewriter, and she said, well, they don't know how to use these things. So I think it was a machine learning application. You know, this year is significant for a number of reasons. 50 years ago, we made it to the moon, right? Neil Armstrong, Buzz Aldrin. But many of you may not know, 50 years ago, we also sent the very first internet message. Dr. Lynn Kleinrock at UCLA made a connection to Stanford University. And the significance of that on October 29th, 1969, a great story, but that was really the first node of ARPANET, what later became ARPANET, but the very first connection, and Dr. Kleinrock did some work in packet switching and protocols. But you know, we made it to the moon that year, we made the first internet connection, and here we are and celebrating at Lockheed Martin our first instance of the Intelligent Factory. On our digital transformation, I want to share some background on the organization. You saw some of the videos. All those products are representative of our 4 business areas. Aeronautics with our aircraft, heavy lift, transport, tactical fighters, strategic aircraft, missiles and fire control with our fire control systems, tactical missiles and energy. RNMS, rotary mission systems, where we have the Sikorsky and training systems, training and logistics, and then space. You saw some of the fleet ballistic missiles and Orion program. So that's a pass around our business. A little over 105,000 employees in those 4 business areas, a lot of facilities across the globe. A number of those are major manufacturing facilities, and a significant amount of engineering and scientists on staff. Heavily focused in research and development, we invest quite a bit. We've got partnerships in industry. Many of you are our partners, as well as academia and higher education. Joe mentioned UCF. I'm partial to UCF in Central Florida. We've got a great industrial engineering program, and if you ever need a contact, Dr. Kowalski does a great job. I'm on the board with him down there. We've got a number of labs, R&D centers, and IP. Okay, so let's get specific about what we're doing on our digital transformation journey. We've heard this a number of times. We're in the 4th industrial revolution. We're focused in cyber-physical systems, and the apex of that is an industrial Internet of Things. We're seeing the convergence of information technology and operational technology. We're a long-standing organization, over 100 years old, and we're taking that OT technology and the great work there and combining it with IT, and that's where we get the industrial Internet of Things. So some examples that we have. Digital twin with our virtual representation in a number of areas, not just engineering, but sustainment, manufacturing, and the components that we build. The Intelligent Factory, which I'm going to talk specifically about, where we're improving movement through processes through our factory and connectivity. The data refinery, we've got our chief data officer here from one of the business areas, Mr. Baskell, focused on how we use data and apply data and build new models. Then we have Control Tower, which gives us a view of how the business is running out through our supply chain and our partners. Some specific examples here are on the Orion spacecraft. We're using AR and VR to simplify complex assemblies and improve our efficiencies there. Combat rescue helicopter, we're using VR for maintenance tasks. Intelligent factory specific, close to me. With F-35, we're realizing some cost savings there as we connect and improve our processes. And we've got some AI tools that go on top of that data that we collect from the factories. Okay, so specific, I want to share some of the recent successes. We said this year was a banner year, and this is a view of one of our wing assemblies on the F-35 in the factory. Last year we were here at reInvent, and we identified green grass as something that we wanted to pilot, bring in, add to a piece of the intelligent factory. 6 months later, we got it in GovCloud. So as soon as it was live, we were there, and we ended up being first in GovCloud. For us, that's a quick turn, that's a quick cycle. 6 months from announcement into GovCloud. We started off on the public side, looking at the capabilities. Now it's part of our solution stack. We have unique requirements that drive us to GovCloud, as many of you are in the industry and partnerships. Our design, we create a new security boundary between the OT shop to the top, where our data lake is in the cloud. And our security boundary here is really what we put in place to secure the machine connections and normalize the data as we put it up to the data lake. We base our model on an MT Connect-like standard. That's a pretty prevalent model many of you probably use, and then we've worked to extend it as we look to use data in context. And one of the interesting things that we learned was latency seemed to be, a question on everybody's mind, but as we're connecting, we're seeing it's not as big of a deal as we thought it was. So we're seeing good performance at this point. Another piece that I wanted to share at one of the other sites here, and it looks like this gentleman is in our session, the silent session with his headphones on. We captured temperature readings on chart recorders, manual chart recorders, and some of you are still doing this. We are still doing this in some cases. But we showed that it's possible to digitally capture those readings from an audit-like quality inspection perspective. We've created visualizations on the data from the shop floor components and machinery up to the data lake, and we've proven that we can ingest that data. And when we talk about data in context, we've started adding manufacturing execution system data to make it more meaningful, and other areas as well as that pipe opens for the OT data. We have unique constraints with manufacturing in some of our facilities. We make fit-for-purpose systems. They're not always commodity-based systems. You see a picture here of the F-35 and some of the coatings. We have unique requirements. So just as your industries and your businesses are expanding, some of you are in our industry as well, we're actually getting pressed to move pretty fast. So our customers are on a transformation as well. And we can't do it by incremental improvements. We've got to meet the demand by transforming, changing how we work, basically. And we're talking things like 10 years to make a satellite reduced down to 5 years. Fast attack recon helicopters in 4 years, right? So our lead times on product lines are shrinking. And it may sound like a long time for some of you if you're not in the industry. That's very fast for us. So specifically, I want to give you an example of some of the components that we're using in the Intelligent Factory. And you can see some of the machinery here on the left, wing assembly and autoclave. And we're connecting those machines and getting the data in an MT Connect-like format, normalizing that data through IoT Core and Greengrass, and that's one of our security boundaries. And then we're ingesting it into our data lake in the cloud. And we use a series of services there, S3, Kinesis, Redshift, and Lambda functions. So we're ingesting that data. We call it shop to top. We're going from the shop floor, pushing that data up, crossing the security boundary, and normalizing the data so that then we can put it in context with other systems and other machines and other facilities. So then it becomes very useful. It's not a specific work cell, a specific machine. We can then start to scale out. So, we're streaming data now from the OT machines to the data lake, from the shop to the top. Another piece that we're starting to build is the digital twin. And that was in one of the videos there a couple of times in the Future of Work video. And you saw a digital twin of the aircraft. We have various digital twins in design and sustainment, as well as in the factory here. So this is an example of one of the Mazak machines in our Grand Prairie facility. And we created a digital twin. So on the left, you see the physical asset. On the right, you see the virtual asset. So this is one of many components, many machines in our factories. And we were able to create that. And I'll give a hat tip to Greg Doppelauer and Jeff Baskell here that's with us for creating this digital twin. So now we've got a physical in the shop, a virtual digital twin, and we start to see the components. So it's nice that it's visual, but what is it doing? And so we've started building visualizations to see what that machine's doing, to get machine states. And I'll tell you, one of the interesting things that started to happen is, in particular, not on that specific Mazak machine, but on tube bending machines, we've started getting a higher level of fidelity that translates into pressure readings that are critical for the air platforms and airframes that we build. So we're seeing a higher level of fidelity and discrete data coming off of the machines that in some cases we were not aware of before. In this case, you see machine states on that Mazak machine. You can see the angles, and we've started to pair this up with manufacturing execution system data to make it meaningful. So now we see the state of the machine, and now we see the manufacturing execution system job that it's running on, and now we can see the operator and the line of business it's supporting and the customer. So data and context is absolutely critical. We can't get to something like Joe mentioned, operational equipment effectiveness, unless we have data and context, quality data, production data, OT data from the machinery, manufacturing execution system data, planning data, and so forth. We can't get to that equation without those data sets. Also in the digital twin, I want to give a reference to one of the projects we learned about last year. And a gentleman named Tim Wilson on the AWS team was here sharing the conveyor, and some of you may have seen that. We've used this in a number of ways. We've used this as a way to show the art of the possible, and we've used it as a team building exercise. So when we go into factories, we're using a technique, we call it internally just do it events, or hackathons would be a common name. And we sort of swarm on a factory and instrument machines and build data products. Well, part of that, we've started to do team building type exercises, and one that we did was build these conveyors. The conveyor is a physical product. You 3D print it, build a PCB, put motors in it, and it runs as a factory conveyor. It's about 14, 16 inches long. It's got all different components. So you physically assemble it, and we did this in teams, and then you control it through the cloud. The project's in GitHub. Tim Wilson's not here, but he's done a great job designing this. And we've used it to show the different components. One of those is digital twin. One of those, Greg Doppelauer is out here. He extended it to use Alexa to use voice controls. So we've got now this visual representation where we can explode out the BOM, the bill of materials, and see the components inside this, where we could then potentially reorder a motor. We could reorder components if we're tied into the supply chain. We can see what's inside that machine. We can diagnose problems. And if you pair that with the prior example of what the state of that machine is, then I can start to pull that digital twin together and make decisions. I can see my run times, my state of the machine, the condition of the machine, and ultimately get into a predictive maintenance type mode. So this is a really neat project. Tim's got it out there on GitHub. You can pull it down like we have. The source code's out there, and then you can 3D print your parts and build this. But what's neat is, you see the technology components here, iOS and Android, you can control through your phone. We used Sumerian to do some of the imaging, and it's a great example of showing the art of the possible. So we've used this as kind of a North Star inspiration type deal. We certainly don't have this on all of our machinery yet in all of our factories, but it's a great technique. Okay, so I want to summarize in saying we're on a journey. We have just started. We've created our intelligent factory. We're going to continue to build on that. We've got 5 sites connected now, dozens of machines, and we're still learning and iterating on how to use that data that's spinning off. So, one of the first things that people sort of struggle with is, how do I tap into that data? If it's local resident on a PLC, how do I get to that data? How do I expand out to a work cell? How do I expand out to a line of business? We're starting to do that, and you saw some of the components that we've connected and how we're using the data. We'll continue to expand with integrations with enterprise resource planning tools, with manufacturing execution tools, quality tools, personnel tools, and staffing, and so forth. So, with the Intelligent Factory here, Alex Moses is one of our engineers. He's written a number of adapters that we use to connect thermotrons and other components in our factories. Alex has done a great job building these adapters. We put them in what we call our software factory, and Chris Bennick's here representing the software factory. So we have the Intelligent Factory, and we have software factory. So we have largely a code base now of our Intelligent Factory using the CI/CD pipeline and tools that Chris's team has built for us. So you see the synthesis of a couple of initiatives coming together here. But as we connect more, as we develop more adapters, they're available across the corporation. They're available across the business areas. We'll increase connectivity in the machinery and tooling. And ultimately, that leads us to improved quality, improved efficiencies, and back to what Joe shared, those initial use cases in the A&D industry. We're probably not unique in trying to reduce downtime, trying to increase mission capability, reduce MICAPs and shortages. Basically, we want to keep our aircraft flying, keep our products in the field, and support the warfighter. So the better we can do that, starting with the Intelligent Factory, where we build and manufacture our products and platforms, we'll all be better off. So with that, I just want to summarize Alex's statement here. Intelligent Factory creates a cyber-secure convergence, that's that security line, of OT and IT for transparent modern-day decision-making using modern development techniques, and certainly the cloud is part of that. So when we go back to those 4 revolutions, we're in the cyber-physical 4th industrial revolution. The cloud is certainly part of our Intelligent Factory, just like electricity became part of our factories at the turn of the century. So with that, I will close. Joe and I will be here for questions. Joe, do you want to add anything?
I will. For those who may have wanted to ask a question, I'm going to ask some questions. So I'm going to put you on the spot.
Okay.
Culturally,
Yep.
Was it a big barrier on the floor to get everybody engaged and work? And what kind of mechanisms did you put in place?
Yeah. Culture is a huge thing, and we operated using those Just Do It events, and I'll be happy to talk to you about it. But really, it's like if you read up on best practices for hackathons, we would come together, we would bring OT personnel, shop floor operators, facilities, engineers, production operations, manufacturing technology, and some IT people as well. And we would focus on making their jobs easier. And so we couldn't come in with just the technology piece, but we had to understand the process, how they're working, how to be more efficient, in some case get embedded with them and do a day in the life type scenario. Many of you probably use that technique, but then work to improve. So the benefit culturally is, when we do these things, when we work a week at a clip, a couple weeks at a clip, we can leave a physical site and now we have connectivity, we have data products, we have insights that we didn't have before, so essentially we're better off. But culture is a huge thing. As technologists, I think sometimes we need to recognize that, maybe more so, and increase our communications and really understand the processes, particularly in this case with shop floor operational technology personnel.
Great.
Anything else?
What was the hardest thing that you went through?
Hardest thing is connecting machines. building the adapters and understanding where to connect, how to connect. We've got a good model. We're certainly iterating. But the first thing was just getting in. And I'll tell you, if you ever watch, I think, what is it, the marshmallow exercise on YouTube, there's a TED Talk about it, where the kindergartners actually built a marshmallow tower out of sticks and marshmallows, and they beat the MBAs and they beat the CEOs. It's a great video. It's a great exercise if you want to do it with your team. But just go do it is the key. So we started, as soon as we got back from reInvent last year, we started building. And it wasn't what we have now, but we started, and we continued to iterate. We grew some momentum. And here we are today, right? We've got an intelligent factory. We've got a minimum viable product that's coming out next year. We're in beta connections right now. So it's continuing to grow. But I would say just get started. Sometimes the hardest thing is where to start. Just go do it. Okay. With that, I'll be up here for questions. Joe and I will.
Let me finish everything out.
Okay.
So there are some related breakouts that I think would be important for you guys if you haven't seen them around for aerospace with GE Aviation. Spirit was actually on Monday, but if you go to the Deloitte booth over in the expo, we can get them to talk to you about Factory of the Future as well. There's one on predictive maintenance within IoT. We put in travel and hospitality, but it's important because those who are working with aircraft, commercial aircraft, and the customer experience and how that's changing, if you're on that side of the fence, you can work on that piece. And then also, we see that automated ground vehicles and autonomous ground vehicles are really becoming the next thing that are going to take and drive efficiencies throughout the factory floor. So please try and stop by that one, Embracing the Next Wave of Digital Transformation via Smart Robots. And so we also have a manufacturing networking lounge in this building up on the 3rd floor, right, in the Ironwood foyer. Our manufacturing team's going to be there. I'm going to be there for Q&A as well during those times. So I'm trying to just make sure that we do some of our house cleaning here. And with that, I want to thank you all for attending and appreciate your time. I appreciate your time, Jeff.
Yeah, thank you.
And thank you.
Honored to be here. Thank you. And glad to be a part of it.